All right, looks like, yeah, folks are coming in, so good to see some familiar names. Someday we'll get to see faces too, which will be great. All right, well, it is noon, and I've got a little bit of introduction before the main event. So I'll go ahead and start talking while folks drift in. It's good to be with you all again. Thanks to our sponsor, Idaho Power, for hosting this BSUG, Building Simulation Users Group, and various topics related to energy efficiency. So our team, for those that might not be familiar, we're a branch of University of Idaho, College of Art and Architecture, and we just had the great joy and sorrow of graduation. So the folks on the left-hand side of the screen, Jason, Tyler, and Kelsey, all graduated, were fantastic, and are off to new careers. So we wish them well. So we'll be looking to bring on some new students this next year. Thankfully, Isabel, Joseph, and Mallory will all still be staying around, and they're just a delight to work with. So we are dedicated to education, outreach, and technical support for high-performance, energy-efficient building design. I know that's a bit of a mouthful, but I think it's helpful to just have that as our continuing mission statement. And I think we'll be hitting a lot of that in our program today. Education on lifecycle assessment, outreach to you guys, and hopefully some new technical resources on high performance building design. Just a reminder that we also have our energy resource library available, close to 1,000 different tools. We have some new tools in on particulate matter that are just about ready to be checked out. So if you're doing some indoor air quality monitoring and things like that, let us know. This is free and available to anyone within the Idaho Power Service territory, and we can do training on how to use these tools, any assistance that you might need. You guys know that we're hosting a BSUG lecture today. This will be our last one for the spring. We're going to take a break over the summer, kind of like the school year. We'll resume in late August on benchmarking and Energy Star, so I'm excited for that lecture coming up. We also have our technical design assistance program. So if you have a new technology or a new building design that you're curious about, but might need a little bit of assistance, that's what, us research faculty and graduate students are here to help with. Not to do your job for you, but to teach you about something new and to bring that new knowledge, new expertise into your office so you can provide that to more clients and get competitive advantage as you pursue, new energy efficiency technologies and design opportunities and things like that. We can help post design charrettes, whatever you need. If you're curious, send us an email, look on our website, there's a quick form, and we'll be happy to help out. Idaho Power also has their own commercial and industrial energy efficiency program. So please check out their website. I see Andy and Sheree and Chris on here, so feel free to message them if you've got something that comes up during this lecture, as well as their new construction and major renovation program. So there's some incentives out there and a lot of opportunities to really help enable Idaho businesses to perform at a high level and reduce utility costs for the rest of us. All right, with that, I'm going to stop share, and our speaker should be able to bring up her slides. And it's my pleasure today to introduce Victoria Herrero-Garcia, a senior sustainability and carbon project manager for Ambient Energy, a Mead Hunt company. And she enjoys initiating embodied carbon conversation with teams early in the design phase. I love that. Integrated design is all about early design phase opportunities and helping develop sustainability strategies to achieve carbon reductions. So Victoria holds a bachelor's degree in architectural engineering from La Laguna University in the Canary Islands, Spain, and a Master of Science in Sustainable Design from Philadelphia University. She's volunteered and collaborated with numerous professional groups, really all dedicated to reducing carbon emissions. And Victoria, it sounds like you have a passion for conserving our natural resources and even have some hands-on experience with building straw bale homes, which sounds really interesting to me. So I appreciate your time today, and I look forward to learning about whole building life cycle assessments. So feel free to take it away. Thank you.
Thank you very much for having me. Before we start, I would like to ask if there is anybody else within a discipline that is architecture or mechanical engineer. So are there any structural engineers? Are there any electrical, general contractors, or any other discipline? You can put it in the chat if you have any other background. Thank you, Henry. Electrical engineer, mechanical. Yep. So mostly I see that architecture, mechanical engineer, electrical, and that's all. That is our audience. Okay, well, thank you all for coming today. I'm going to be talking about embodied carbon and whole building life cycle assessment. And to begin with, I work for Ambient Energy. We were a small firm located in Denver, Colorado, and we just were acquired last September by a larger nationwide firm called Mead Hunt. So now we are Ambient Energy, a Mead Hunt company. Still, we are working towards a resilient and regenerative built world, and that is what we try to do in all our projects. Our services, we have building performance engineering and sustainability consultant and commissioning services, but today I'm going to be focusing mostly in what I do with the whole building life cycle assessment and the net zero carbon consulting. So what is the difference between operational carbon and embodied carbon? I know it's a little hard without a poll or anything, but if like, can you tell me yes, no, just put in the chat a why or a no, like, have you heard embodied carbon, how much experience, like if you have heard or you have experience, just say yes. If nothing or very little, you have heard but not much, say no. Okay, sounds like there's a lot of yeses. So that is pretty good. I'm looking forward to have a great conversation with you all then. Awesome. So then, as you know, or for those that don't know much, operational carbon is the carbon that is emitted during the operations of the building. So when the building is completed and construction has ended and starts to be occupied, anything that is lighting, mechanical systems, the water, anything that is all usage of the building is the operational carbon. And the embodied carbon is all related to the materials that are used to create this building. So in a little bit more detail, the materials have different life cycle stages. So they come from extraction, from manufacturing, transportation, installation, replacement, and end of life. You can also hear about embodied carbon being called global warming potential. The unit of measurement is CO2 equivalent, kilograms of CO2 equivalent. And the reason why it's equivalent is because it's not just about CO2. There are other greenhouse gases that could be also taken into the equation. When we look at a global CO2 emissions by sector, then we can look at how is it broken down. This is a graph created by the Carbon Leadership Forum, adapted from the Architecture 2030 and different data. And if you look at the big part of the pie, of building operations is the biggest chunk with 28%, But if we look in more detail, then with the 11% and the 10% with building materials, it does account for close to 21%. This is important because this was a study that I was at in 2020. So I keep discounting years and months every time that I talk about this. So right now, already part of this 2.5 trillion square footage of buildings that are shown on the title of the slide, they are already built because this report was in 2020. So if you put this into perspective, this equals to building one New York City each month. And if we put it with what is left to 2060, we have 463 New York cities that will be built from now to the end of 2060. Operating versus embodied carbon, operational carbon, when we have a building as usual, again, the operational carbon will have the biggest impact in the building life cycle, and the embodied carbon will be the little part of the pie. But when we're going more towards high performance buildings, the greening of the grid, and the operational carbon starts being reduced, and the embodied carbon takes a bigger place on the impacts that these buildings will create. I have this video I really like. I don't know if you are familiar with Amanda Gorman. She's a poet, and she has a very impactful video that was posted by 24 Hours of Reality, and it's called Earthrise. Let me know if you cannot hear it.
On Christmas Eve, 1968, astronaut Bill Anders snapped a photo of the Earth as Apollo 8 orbited the moon. Those three guys were surprised to see from their eyes what a planet looked like an Earthrise, a blue orb hovering over the moon's gray horizon with deep oceans and silver skies. It was our world's first glance at itself, a first chance to see a shared reality, a declared stance, and a commonality, a glimpse into our planet's mirror. And as threats drew nearer, our own urgency became clearer as we realized that we hold nothing dearer than this floating body we all call home. We've known that we're caught in the throes of climactic changes some say will just go away, while some simply pray to survive another day. For it is the obscure, the oppressed, the poor who, when the disaster is declared done, still suffer more than anyone. Climate change is the single greatest challenge of our time. Of this, you're certainly aware. It's saddening, but I cannot spare you from knowing an inconvenient fact, because it's getting the facts straight that gets us to act and not to wait. So,
okay, I have the link there. So if you want to listen more to the poem, it's pretty powerful poem, and I think it puts very well together why are we all doing this? Why are we all here learning today about another way to reduce our impact on Earth? So, oops, sorry. So as she said in one of the last sentences, climate change is the single greatest challenge of our time. And that's a call to action. This is a climate action tracker that warming projections global update from November 2021. And as you see, we are here. Like the Paris Agreement goal is 1.5 degrees Celsius, not increase that. We're already here, and this is the end of 2021. And then there's a lot of text on this slide, but I want you to take this one. more than any of the other ones. But this is like with the most optimistic scenario. This is like every target, every climate action plan, everything that is right now being discussed and talked, and all the calls to actions for doing the best that we can. We still, in the most optimistic scenario, will be a little bit above this goal of 1.5. So there is a lot to do. This is like, sometimes when I look at these graphs and this information, is like, okay, we're doomed. This is like the end. We're not doing anything. But then it's like, no, we are still doing things, and there's a lot of people like you all here today that want to make this a change, a big change. In the US also, we are already having a lot of embodied carbon policy. And this is a resource from the Carbon Leadership Forum, and is updated as of this month. So there are the national policies, are other countries that they have. So I only put the map of the US. So you can see that there is a lot of state or provincial policies already in place, and there's some local policies also in place. But there's a lot to do still, and I hope to next time that maybe we have a discussion again, that Idaho has something there. There are other reasons also why people are doing this, not just because policy is taking place, but also because rating system rewards reductions on embodied carbon. There are rewards based on building and material reuse. There are rewards on low embodied carbon material procurement, and there are rewards on whole building life cycle assessment and reducing environmental impacts of the building. Then also there's a lot of institutions that have come together and say, hey, we also want to have a commitment and a challenge and make sure that we are working together towards these. So the Architecture 2030 also has the Embodied Carbon Challenge. And this was, again, a graph created in 2020. It has not been updated. So the goal was already in 2020 to reduce 40% of the embodied carbon. And then when I present my case studies, you'll see how hard it is actually to get to 40%. So it is a big goal, but it is possible. And then by 2030, the goal is 65% reductions, and then 0 emissions by 2040. And the reason why that was established is to kind of follow a little bit of the 2030 challenge with the energy as well. So that's kind of like the path that they are following. Then structural engineers have come together as well, and they have created this structural engineers 2050 commitment. You can go to the website if you're interested on learning more. There's a lot of information there of actions to be taken and resources of how to even analyze the impacts of the structure on your building. And as of March of, September, it was September, October last year, the mechanical engineers also got together and created the 2040 commitment. This is an initiative that also was supported by the Carbon Leadership Forum. So if you are interested, you will need to go to I have the source down below, to the Carbon Leadership Forum's website and look for the ME 2040 commitment, and it has all the the steps that you will need to follow. I will encourage you all to look at it and sign the commitment. Convince your firm to sign the commitment. So let's go back and like another little part of Amanda's poem, and just, we refuse to lose. Like, we are here together again to keep pushing the envelope and trying to make our buildings more sustainable, because we all like this planet Earth. Okay, but again, if we don't reduce, we can we cannot reduce what we cannot measure. So before we know what we have to do, like with the architecture 2030, oh, let's do 40%. And it seems very ambitious and great. Okay, we're going to do it. But then we start measuring and we are realizing that, whoa, that is going to take a little bit longer than expected, because there is a lot that we need to learn on how to reduce embodied carbon. So there is one of the initiatives with the 2040 MEP commitment is to request low global warming potential refrigerants. I don't know how many of you are familiar with global warming potential values and the impact of each of the greenhouse gases. And there are, the carbon dioxide was determined to be the global warming potential #1. So that is why everything is in correlation with the carbon dioxide. And that's why we have the CO2e, which is equivalent. So methane is 28 times a carbon dioxide. So if we have a fluorinated gas can go from 138 to 23,500 CO2 equivalents. So this is very large when we're talking about refrigerants, because they are all in the F gases, which are 3 different ones, and the fluorinated gases. And then when we start looking at some of the refrigerants that we are using in our mechanical systems, we see that they are for 110 is pretty common. They are 134 is pretty common too. And they have the highest global warming potentials out of all the other options of refrigerants. In Europe, they are using a lot the R123.4CE. Sorry, this one. And they are seeing a lot of good results. There are some jurisdictions in other countries. Unfortunately, the US has not caught up on that yet, with having limits on like what refrigerant you can use in a project. There is some jurisdiction. This example was from SOM, which they did a project in Australia, and the owner establishes 750 as a maximum. No, sorry, that was 10 as a maximum that they established. And in other places is 750 or less. So as you can see, there's a lot work to do on refrigerant selection. So when we are talking still about refrigerants, and we put the operational versus the embodied, and the embodied carbon, we're talking about the refrigerant itself, not the mechanical system. So here the blue bar is the power input from the grid, so how much electricity we're using from the grid, and then the refrigeration leaks, and the manufacturing and end of life is the little gray bar. So when you put all that together and you're going through advantages of high performance buildings and the greening of the grid, and then using low global warming potential refrigerants, you can see the huge impact that right now the refrigerants have in the life of a building. Here is it is a lot of information in this little graph, but or image, but it's kind of like the refrigerant cycle. For those not familiar, I will show you in a minute another more information what it means, the A1, A3, C4, and all these life cycle stages. So the biggest thing that I want you to take from this image is the leakage risk. And so in any stage that you see a little exclamation mark is a possibility for leakage of that refrigerant manufacturing, processing, and usage. And you see that the biggest The biggest mark there, the biggest exclamation point is during the big one, that is the usage of that mechanical system. So there is a huge amount of refrigerant being leaked during that stage. What I want you to take from this is that, one, try to do some research about the global warming potential of the refrigerants that you use in the mechanical systems. Try to reduce that global warming potential, and also try to reduce the leakage of the refrigerant in the mechanical system. Maybe starting with the specifications already requiring some monitoring of the leakage. And now we're going to jump into the materials portion of the embodied carbon. There are two different ways to measure the embodied carbon. One is during procurement, and the other one is the whole building life cycle assessment. So I'm going to start with the procurement of low carbon materials. And for those not familiar, one really important concept to know, or important name to be aware of, is the Environmental Product Declaration, or EPD. For those that you don't know, the EPD gives us the information of the environmental impacts of the product from different life cycle stages, and I will show you in a minute. It is kind of like they call it the nutritional label of a product, since includes environmental impacts, six different impact categories at least. Some reports have some more. Global warming potential, so ozone depletion, acidification, eutrophication, smoke formation, and the energy demand. For the embodied carbon itself, we're going to focus more on the global warming potential itself. As I mentioned earlier, so global warming potential or embodied carbon, same term. So other terminology to be aware of is the system boundary. So I'm sure that you have heard cradle to gate, or cradle to grave, or cradle to cradle. So the system boundary for an EPD is a cradle to gate system boundary that includes the stages, life cycle stages A1 through A3. So the extraction of the raw material, the transportation to the manufacturing, and the manufacturing itself. And normally the system boundary of a product stops there. Some manufacturers have started to do the end of life as well, because they have normally because they have a circularity or recycling program that they will reuse that material at the end of life, repurpose or recycle. But for the most part, is only A1 through A3. So here is another way to see this, put in another type of graph. And again, for the EPDs, for the most part, is modules A1 through A3. Here's an example of an environmental product declaration. This is, unfortunately, there are not many environmental product declarations for mechanical systems. So I have an example of a ceiling panel. Just a few things that I want you to take under consideration anytime that you look at an environmental product declaration. The first thing is that you need to look at the declare product or functional unit. It is on the first square, and then the PCR, which is the program category rule, and that is kind of like the manual for each product category. So all ceiling panels will follow the same PCR, or should follow the same PCR, in order to develop the EPD. If there are different, so if you have two different products that you're comparing and the PCRs are different, or the PCR is the same but the version is different, you might not be able to compare these two products because they are following different standards. Then the EPD scope. This one, for example, has a recycling program, so they do have cradle to grave, but that is not always the case. And then the global warming potential per the functional unit that is always established at the beginning. So how to compare them then and know which product is best or which product is worse is you need to make sure that it's the same declare of functional unit, that the product category rule is the same, and the system's boundary is the same. Otherwise, you will not be comparing apples to apples. And it gets very complicated. So that's why there are tools available to do this product selection. And the most used here in North America is the EC3 tool, but One Click LCA also have a planetary, and they are both free and available to all users. They already have done their work for us, making sure that the declared unit is the same, the PCR is the same, and the system boundary is the same. So you can compare apples to apples. Here are the links to where to find these tools and how to find tutorials and more information. I will provide a PDF of this presentation so you all will have this information. So the whole building lifecycle assessment. This is a comparison between a baseline and a design case. We are comparing and analyzing the impact of our structure and building enclosure in 6 impact categories, the same 6 impact categories that they come on an EPD as well. The system's boundary for a whole building LCA is a cradle to grave. So we use the end of life as well. The system boundary that can be looked in another way with the life cycle stages. So this will be a 1 through C4. As you see, the operational energy use and the operational water use are outside of the system boundary for a whole building LCA, and it's because it's only considering materials, not operational use, the operational carbon. And again, the same graph that I showed you before, the same image, and the modules. So now the modules A1 through A5. So it includes the transportation to the site and construction and installation. Then they use the stages. And I'm sorry, here is B1 through B7, but it's really B1 through B5. C1 through C4, which includes disposal, and that will include all the life cycle stages for a whole building LCA with a cradle to grave system boundary. The most commonly used tools in North America for whole building LCA are the Athena Impact Estimator, the One Click LCA, and Tally. They only One Click LCA and Tally have a Revit plugin. Athena is all a web-based tool that you have to download and then plug in your inputs. You can also use Excel spreadsheet to plug in all your numbers and materiality to Athena. But One Click LCA and Tally can work with the Revit file. The E-tool is also able to work with Revit file or any other. There's Tally is only Revit. One Click LCA and E-tool have also capabilities with other softwares, ISVE and Rhinoceros and SketchUp and other modeling tools. So more capabilities, but the E-tool is mostly the software developers are in Australia and is mostly used there and the UK. Here are all the links to these software tools. And I have a few case studies here to show you. This is a case study that was completed for LEED. We were using LEED version 4.1. and the MRC1 option 4 for whole building LCA. So LEED requires that your system's boundary is A1 through C4. So it includes the extraction, manufacturing, transportation, maintenance, and replacement, and the end of life. So it's cradle to grave. And excuse me, and the life cycle of that building will be 60 years. For ILF5, if you're doing zero carbon for ILF5, if it is 50 years life cycle. So LEED requires that the design option needs to be same size as the baseline, same programmatic function as the baseline, same orientation, and same energy performance. What that means is that if the building envelope, so for energy modeling, you use the ASHRAE if you're doing LEED, ASHRAE 90.1, 2010, 2016, whatever version of LEED you're using, and you establish your baseline values for the envelope for the Appendix G, from the Appendix G, and then for the design, you put whatever the design is. For embodied carbon, if we do that, then the materiality would change and it doesn't really works the same with the energy performance. So normally the baseline for a whole building life cycle assessment is the design pretty much. And the changes will be based on different insulation types, or if the project really goes with a bigger R value or whatever changes are there. But at the end, you need to have the same energy performance with that assembly for the roof and for the wall. Elements to include in the LEED whole building life cycle assessment. They are only the building enclosure and the structure. So the building envelope, roof assemblies, structural walls, and superstructure, footings and foundation, and all the structural floors and ceiling, but no finishes are included. If you include finishes or non-structural walls, you don't get any credit for LEED, but it can be used as a good way to reduce the impacts. So here is one of the example or case studies I wanted to show you. Unfortunately, I cannot be disclosing the name of the project, but here are the models. So the architectural model and the structural model. When we did the analysis, as you can see, the biggest impacts come from the ready-mix concrete and all the steel used in the project. So this is just the baseline, and there is a huge impact on the structure. So key things, structure as of today, unless it's a complete wood structure where there might be the biggest impact might come from the insulation, but for any steel concrete buildings, normally the biggest chunk of the impacts are coming from the structural system. Here's another way to put the information. So when we look at the life cycle stages, as you can see on the left-hand side, A1 through A3, which is the extraction, transportation to the manufacturer and manufacturing itself, are the biggest impact for any material. So the deciding factor of reducing global warming potential will come from, is my product recycle or reuse? Is it salvage? Can I use any of these options? And then can I use any other product that has been produced with a better energy source, or it has been produced with a lot of recycled content? So all those things will help with the A1 through A3 life cycle stages. There is a One Click LCA is the software that I use for the analysis, and we can have a discussion on why I have decided to use One Click LCA. I have used them all, and to date, it seems that the best one to have more capabilities and functionality. So they do have this type of like thresholds and how to measure your building based on the building type that you enter. Not all building types are included in the software yet. So there is some projects that might be generic, or you have to pick like the most similar building type. But for this project, for example, the kilograms of CO2 equivalent per square meter are 312. That's the baseline, and it's on level C, which is good. It's not too bad. The ILFI has as a threshold, I don't know if you're familiar, but there are, they have established a threshold for any building type of 500 kilograms of CO2 equivalent per square meter. So this project, for example, just the baseline will meet that threshold. So the design option that was analyzed, well, I didn't mention before, the structure, the foundation was concrete, and then the whole structure was steel, including a steel deck for the roof. So one of the design options that was considered was to change all the high roofs. So there were some high roofs and lower roofs. So all the high roofs to be cross-laminated timber instead of a steel deck. Just with that change, we only were able to reduce 11 kilograms of CO2 equivalent per square meter. If you look at the end, it's 3.4%, just one little change. But just with that, is like, you can see how hard is the 40% to achieve the 40% reductions in reality. It's like, we are not there yet. We're close, we're getting there, but it is not that easy. So in order to make further reductions, I'm not sure if you're all familiar, but any wood during the time that tree is growing is absorbing CO2, and it gets captured in the wood. And that is when we talk about the biogenic carbon. So if we take under consideration the biogenic carbon, then we are reducing the embodied carbon of this building by 13%. So a little bit better. And then we looked at other option with CLT, and also having the concrete with 20% fly ash or any cementitious substitution. And it came out of 5.6% reductions. And then we also started analyzing different products, like what if we use EPDM instead of TPO? So the TPO is on green, and the EPDM is in brown. So when we compare the two products, and we see, and this is doing a whole building life cycle assessment. So this is including the replacements if needed for the life cycle of the building that is 60. So normally that is taken under consideration, and also the end of life, that is the assumed end of life for this type of products. So with that, we see that the TPO performs better than the EPDM. The project was also very interested on knowing what to do for the wall assembly, for the continuous insulation that was going to be used for the wall assembly. And that was an R value of 10 that wanted to have. And the product that this project was going to use, or was looking into use, is number, well, all of them are number 2, sorry. So XPS NGX 250. I don't know if you're familiar with these products. It's the Formular from Owens Corning, and it has a water barrier as well on the product. Not a water barrier, but it's water repellent. So you avoid having to use a water barrier as well. So with that, we were looking at this product, and compared to any other XPS, it was performing pretty good. Even this other XPS from Kingspan, this one was across the board was the best. But then we look at the ozone depletion, the ozone depletion, and it is huge compared to the other ones. And the reason is that they use CFC 11 for the manufacturing of this product. So the end of the story, or wrap up with the insulation analysis, is that there is not, unless you come to like mineral wool, for example, the global warming potential is the lowest and the ozone depletion is low, but the acidification is high, the eutrophication is decent, and then it uses a lot of energy to produce. So this one, the thermofiber product. So this is product specific, manufacturer specific, but the end of the story is that it is not as easy as we think, like just to grab 2 EPDs or to grab 2 products and say, oh, this one is better than this one, if you take under consideration all the environmental impacts of any product. There are some resources, I think, for all of you mechanical engineers with wanted to learn more about the refrigerants. The first resource will be very helpful. It has a lot of really good information, and Bureau Happel are part of the ME 2040 commitment committee, let's say. And they are working on a tool for refrigerant kind of like global warming potential with a refrigerant, with a mechanical system. So if you decide to use a chiller versus a, I was going to say boiler, I'm not an expert on mechanical systems, forgive me for that. But if you choose different mechanical systems, then you can see what refrigerant options you will have and what the impacts of those refrigerants will be. There is also some resources with EPA, with the assumptions that they have of like each, not based on each refrigerant type, but based on, I think, in each different mechanical systems and how much they leak per year and how much they leak, they will leak within 2-year period or the lifetime of that mechanical system before it needs to be replaced. Take action. I will encourage you all to look at the commitments for architects. Go to the Net Zero Carbon Buildings commitment. You can also make sure that you have your structural engineers on board and they look at the SE 2015 commitment too. There is the owner's can, which talks about kind of like implementing embodied carbon policy within a portfolio for developers, real estate portfolios. And then there's commitments for contractors. So there's a lot. And again, that integrative process, that conversation that should be happening from the beginning of any project, you don't be shy. Mechanical engineers also have a word. Let's say that the structural engineers didn't have much of a word, and now they are talking about these impacts reductions and how we can all collaborate to make it happen. So to maximize embodied carbon reductions, reuse and reduce, have early conversations, set up targets from the beginning, do low carbon procurement. So select products based on the global warming potential, utilizing the free available tools, EC3 tool and the OneClickLCA planetary. Include all disciplines from the beginning. And then for you all, request low global warming potential refrigerants and MEP EPDs. So environmental product declarations for the MEP systems are very important to start asking for because there is very little. And with that, I want to leave you with an end of the poem and just open your eyes. The tools are there, the resources are there, people that can collaborate together and wants to do so are there. So just keep up the conversation. Thank you very much. And now I think we're opening up to questions.
Yes, thank you so much, Victoria. I appreciate it. And yeah, Dylan just launched a poll, so I'd love to hear more about you. And if you have thoughts on future topics, please feel free to send them in. So our first question came up during that case study example where you were talking about the one-click, that Justin's saying, do you consider one-click better for lead documentation or for the whole process? Because he's heard that it's difficult for teams when the materials are more generic very early in the process.
Yeah, that's a great question. So it is more of a holistic way to see it. And I can also send you a link to an article that I wrote about comparing the three softwares, the Athena, the OneClickLCA, and Tally, and the functionality of each of those. So there's just, I'm gonna try to be short, but Athena was developed in Canada, so they have the databases by cities, and there's very limited amount of information for US cities. So even if you have a project in Idaho, you might need to select the location from San Francisco or maybe Vancouver. You kind of like in the middle, so you will be able to select one or the other, which is very different, like the materials that you will be using and like the life cycle of that product will be different. So it is limited on that way. It is limited on like not being able to use it with any 3D modeling tool. And it has a limitation also on the amount of environmental product declarations that they are available in their database. So that is Athena. Tally was developed to be a Revit plugin, so it only works for Revit. And if you don't have a Revit file, you cannot use the software. It is very easy to use. It's very user-friendly, same as OneClickLCA, but you need a Revit file. So OneClickLCA allows you, so at the end of the day, the biggest impact in embodied carbon reductions happen if you have early conversations before the estimates are final and the pricing is final for every single product and material. So the earlier you start the conversations, the biggest impact. And if you don't have a Revit file, how do you do the calculation? So how do you estimate these numbers? So OneClickLCA does have that capability. They have the carbon designer tool, which is like early modeling kind of. You can create the building, and it's based with a based on climate zone for the building assembly, and it is based on a standard structural construction based also on the location of your project. So it kind of like creates the model for you. And also, if you don't want to do that, you can plug in your numbers directly to the software, just type them in and put them there, materials and number and quantities, and or you can use an Excel spreadsheet and input all that there. Athena can do that too, but then you don't have as many products to select from. So there's a lot of, it is a lot. So if you want to discuss further, we can talk more, but there's a lot of different reasoning.
Thanks. Yeah, and if you do send us that link, we'll post that along with the slides, with your lecture on BSUG, and we can direct to your website as well. Have some comments here of just a very helpful and informative discussion, which I'll second. And a question on the difference from Mehdi about the difference between LCI, LCIA, and EPDs, so the environmental product declarations and then others.
So they are interrelated, but LCI will be the life cycle inventory. And that is kind of like if you go to a manufacturer and you tell them, what is your process, where your materials come from, and where they they are extracted, what is the transportation, then how much water do you use, what is your energy, how do you cut this product, what do you do with this little piece that is missing here. So that is kind of like the process itself. So you do a life cycle inventory of what happens in the process. Then with that information, you can implement the life cycle assessment, which is the LCA, and that will include the environmental impacts. So then you multiply all your life cycle inventory data by the impacts for each thing. So the water has an impact, the energy has an impact, the extraction has an impact, and that is giving you already starting to give you the global warming potential, the acidification, the ozone depletion, and all the categories that I mentioned. And then the EPD is the report of that LCA. So that is the kind of like the final product that explains what is the process, what are the units, and it doesn't include all the LCI data because it's a lot of information, but it kind of breaks down in big picture of what was included, and normally follows a PCR, the product category rule. So depending on the material type, you will have to use a different way to do that assessment.
Okay. Thanks. Yeah, and I was really surprised. I guess I shouldn't have been, but one of your early slides was showing, as you're looking at the whole building life cycle assessment, as the building gets more efficient, the embodied energy takes up a much larger portion of it. But when you're making some of those early decisions, about, like the case study that you showed about insulation, or even more like refrigerants, I'm assuming you're still factoring in those operational impacts if those different materials have different operational performances. Like are the other refrigerants, coming out of Europe that you were mentioning, do they have the same performance as R410A, or are you going to have to run your chiller more often? And is that considered within the energy model that you're doing?
That is a great question, and I want to research further on that. I don't know the answer to that. Again, I'm not a mechanical engineer, and I really, the information that I just presented to you about the ME 2040 with the refrigerants, it was presented to me through the Carbon Leadership Forum like a month and a half ago, and it has a lot of really good information, but again, that is mechanical engineers, which I don't know. I remember very clear that somebody asked a similar question, and somebody answered that the R1234, the thing is that those are the numbers, EC, was available in the US, and it performed the same as, I don't remember which one she said, but yeah, I will encourage you all to contact MEP 2040 and ask all these great questions to their expert team.
Thanks. Yeah, and our lab's doing a little bit of research. I see Lindsay Watkins on here. She helped when we were doing some initial residential comparisons as well, looking at, as well as Teus Mitchell is on here too. Where we found, looking at wall materials, the R value of that, looking at a 50-year lifespan, just had a huge impact. It seemed to dwarf, some of the other components. So I'm wondering if, One Click LCA or the other tools that you mentioned, Tally, if they can be applied within, a residential or multifamily, or if you're primarily working on lead commercial, like where's your work usually, and in what sector is that?
So it is all based at the end of the day on like the only one that will give you a kilograms of CO2 equivalent per square meter, kind of like the thresholds and how your project is doing, is the One Click LCA, and you select the project type. So then it will vary depending on project type, but it's all based on their database that they have on different projects that people are completing, and they have those values. So it is still a little subjective. In order to really do a good analysis on different assembly types based on different R values, I would suggest that like Tally, you will have to build the assembly in Revit and with the thicknesses and everything in order to use Tally. Also, although Tally has a capability to change thicknesses, so you could do the assembly, just the materials, and then use Tally. Or you could do with One Click LCA or Athena, you can just plug in the assembly type and then compare different R value, like different assemblies for the same R value using the EPD. So you're gonna have different, using different tools, you will have different results because each of those tools have different EPD databases. So depending on the product that you choose, and then they all have slight different assumptions with energy used for the material production or energy used within the location of your project. So it is there's a lot of variables.
Okay, yeah. Well, I see we're just about at time, but I do, want to leave it open for a couple of other questions. There is one question from Eleso, and was concerning the context of these tools within Africa, where there's fewer LCA studies and databases like you were talking about. So on the material of construction, which indicator is the most important in your eyes?
Yeah, so I don't know if you were able to see the part where I was showing the case study, Ilaso. I'm sorry if I didn't pronounce it right, but there is the biggest impact always come from the material extraction and manufacturing. So the if there is no data, not much information about the transportation and the replacements and the end of life of that product, I will always base the analysis on like EPDs of the materials that you're gonna use. I will try to select the closest location. So if you're in Burkina Faso, maybe, I don't know, like Southern Europe, somewhere like the closest to Africa, whatever information you can find from there. One Click LCA again is a worldwide database, so there is a lot of information from other countries. So you might be surprised that you find something closer to your location, or maybe some Arabic countries have more EPD data. So I would suggest that you look at the One Click LCA or the E2. That those would be the best whole building lifecycle assessment tools for projects outside North America.
Thanks. Any last questions from the audience? Feel free to unmute yourselves if you want. All right. Well, thank you so much, Victoria. I'm sure there might be some follow-on emails from people.
No
but
problem.
I so appreciate your time today, and I certainly learned a lot, and I look forward to checking out many of the resources that you posted in your talk. So thank you for sharing those. I really appreciate it.
Great. Thank you very much. And thank you all for having me and being here. And please have conversation. Talk about it.
We will. We will. All right.
Great.
Thanks all. And for everybody that's on the BSUG team, we will see you in August on Benchmarking and Energy Storm. So thank you all.
Bye.